Hello.
Yeah, I can hear you. Yeah.
Sir, can you hear me? Yes, sir. I'm Pushkala, sir.
Sorry, Pushkala.
Yes, sir. Pushkala.
Okay. Sure. Okay. Just hold on. Actually, I think the class is rescheduled today. People don't actually. It was updated in the portal. I don't know. I waited up to six
Yes.
fifteen. Okay, wait. Just let me wait for 5 minutes. We can continue. No problem. Okay. I think two
Yes.
three people will join.
Yes, sir. Thank you.
Just Okay, Pushkala, we can start. I think most of the people don't know. Anyway, no problem. Um, yeah,
Sir, I'm messaging. I'm trying to message them.
sorry.
I am trying to message them, sir.
Yeah. Please message.
I am emailing. I'm emailing. Yes, sir.
Okay, so will I wait for a few minutes?
Yes, sir. For 2 minutes, please.
Okay, sure. Just let me informed. Okay.
Yes,
Okay.
sir.
Okay.
Excuse me, sir.
Yeah, yeah,
Excuse me, sir.
yeah, 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 yeah. I can hear you. Yeah. Hello. Yeah, I can hear you,
Hello.
Pushkala. Yeah, yeah.
Sir, sorry, I can't hear you.
Sorry.
Hello,
Yeah,
sir.
yeah, I can hear you. Yeah, Pushkala.
Yes, sir.
Yeah, please tell me.
Sir, I have a message. I have emailed them
Huh. Oh,
in one of the groups. Sir.
okay. So no one is joining.
No, sir, I didn't get any reply.
Okay. So if you wish, we can continue. There is no problem. We can discuss some solutions if you want.
Uh, sir, okay, sir, for me, I will.
Huh? Sorry.
Sir, yes, sir, we can.
We can continue, right?
Yes, sir.
Okay, sure. Don't worry. We'll discuss the solution. If you have any problem, please ask me. Okay. This will be one-to-one
Yes,
session for today. No problem. Okay. So I'm sharing my screen. So I forgot. You are doing your MSc or
yes, sir. I'm pursuing my MSc now
you have done already
in
your
one of
MSc?
the. Sir?
You have already completed your MSc?
No, sir. I'm pursuing now in one of the state universities of Andhra Pradesh.
Okay, okay, okay. You are pursuing your MSc, right?
Yes, sir. Yes.
Okay, okay, okay. Okay, fine. We'll start. We'll do it slowly today. No problem. Okay.
Yes, sir.
Okay, sure. Is my screen visible?
Uh,
Is my screen visible, Pushkala?
yes, sir. Yes, sir.
Okay, okay, fine. I think people have joined. Let me check once. Yeah. Hmm. Okay. Milan Prajapati, you are joining for the first time?
No, sir. I
You joined?
have
Oh,
missed
achha.
some class.
Oh, oh, okay. Sorry, I couldn't recognize. Okay, fine. Can you just introduce yourself again? I forgot actually. Milan,
Can you, sir, repeat?
can you please introduce yourself?
Yes, sir. I am MSc Physics student in second year,
Oh, you from where?
Gujarat University.
Oh, okay, okay. Fine. You joined this session in the previous sessions, right?
Yes, sir.
Okay, okay. Okay, fine. We'll start today. Okay. Actually, the schedule was a little bit changed. That's why there's some confusion among the students. Okay, not an issue. Is my screen visible? Can please anyone tell? Pushkala,
Yes,
Milan?
sir. Yes,
Okay,
sir. Yes, sir.
okay. It's visible, right?
Yes, sir. It is visible.
Okay, fine. Okay, then let us start with our first question. Okay. So this is a question from GATE Physics paper 2020. This is a MCQ question having 2 marks from quantum mechanics. So this question is the Sx cap operator denotes the spin operator defined as Sx cap equals to h cut by 2 times this matrix 0 1 1 0. So which one of the following is correct? So there are 4 options given. First option is the eigenstates of the spin operator Sx cap are up spin, this state is 1 0 and down spin state is 0 1. Option B is the eigenstates of spin operator Sx cap are up spin is 1 by root 2 times the matrix 1 minus 1, and this will be down spin will be 1 by root 2 times 1 1. Option C, in the spin state, 1 by 2 times this column matrix, that is 1 root 3, upon the measurement of S cap, the probability for obtaining a spin state is 1 4. And the last option, option D, in the spin state, 1 by 2 times this matrix 1 root 3, upon the measurement of S cap, the probability for obtaining a spin is 2 plus root 3 by 4. So there are 4 options. You have to choose the correct one. Pushkala, can you switch off your mic? Actually, some noises are coming.
Yes, sir, it is on mute.
Yeah. So, is this question is now okay with everyone? Is there any confusion with the question?
No, sir.
Okay, please try to solve this and let me know which is the correct answer for this question. So, okay, please take your time and try to solve this. So, hi Amit, you joined now, right?
Yes, sir. Sorry,
Okay,
sir. I
no, no,
didn't.
it's okay. Actually, it was updated in the portal, but I don't know, student has not checked, so it's okay. Actually, I have some
Okay.
work tomorrow, that's why I have to reschedule this class today.
Okay, sir.
No, not an issue. So just read the question. This question is very easy forward and try to solve this. Take your
Yes,
time.
sir.
Okay. And if you have any confusion, please ask me. So can anyone tell me how to solve this problem? Any how to proceed? So what about the first two option, Amit?
So this is MSQ or MCQ?
MCQ. It is written MCQ. You can see on the top. This is the MCQ 2 marks question. Okay. So the
Okay.
only one option will be correct for this question.
Okay, sir.
Okay.
So B.
Option B.
Yes.
Sure.
The eigenstate. Oh, okay. H.
So there is one is mistake in the question, but not mistake actually. This will be downspin. Okay. So first one is upspin. Second, there is a printing mistake in the question. So second one is the downspin. So it is given here both are upspin. So there is a typo. So this is for upspin. This is for downspin. Just consider it as a downspin. Just just check it carefully, because if you got the answer within first two options, then it's okay. I mean, otherwise you have to check for the other two options also. So what about the first option? Any idea, Milan, Pushkala?
No, sir. Sorry.
Okay, so did you read
So
about yeah,
the eigenstates I have found that is matching, but H by 2 is not there. So A
h by
B
2, so
can.
why h by 2 will not be there in the eigenstates, obviously.
Oh, H.
So
Okay.
so yeah, No, I'm yeah, Milan. So I was talking to you. Just hold on, Amit. Okay. So you read the spin in quantum mechanics? No, the chapter spin.
No, sir.
Oh, okay. Okay. So do you know how to find the eigenstate of a matrix or
Yes,
eigenvector?
sir. Yes, sir. Yes.
Can you just find the eigenstates of this matrix and can you please tell me eigenvalues and eigenstates? You can do that, right?
Yes, sir.
So if you can do that, then you can be sure whether these two in your any of the options will be correct or not. Okay, just do that and let me know what are you getting. You are getting between these two options or not. So yeah, just check that. What are the eigenvalues and eigenstates or eigenvectors? Amit, you also do that. If you don't remember, actually, I hope these things will be
So,
remembered. But yeah,
sir, I've done means I found the eigenstates
what are the
and
eigenstates then?
1 by root 2 1 1 and 1 by root 2 1 minus 1.
So 1 by root 2 1 1 for upspin or downspin.
Uh, okay, sorry, I missed
So
that.
because there
I'll
will be two state, right? Upspin and downspin. So uh, you have to know which is upspin and which is downspin. So upspin will be will have the positive eigenvalue and downspin will have the negative eigenvalue. So that's how we define this. Okay.
so B is wrong because 1 1 is
Yeah.
coming from plus 1.
Exactly. So B will not be correct. So that you are sure.
Eigenvalues are h
Yeah.
cross by 2 and minus h
Minus
cross
h
by
square by
2.
2, right. So for that, what states you will get? So you have to know the actually this should be known
I
if
think,
you have yeah, please tell me. Yeah, Milan,
yes,
please
sir.
continue.
Bec- Sir, I got only
Yeah,
eigenvalues.
please find the eigenstates also.
Actually, eigenvalues for Pauli matrices are always plus minus 1.
Yes, obviously that will be same, but actually this is the common thing that Sx, Xy, Sz you should know the eigenstate at least. You should remember.
Yeah.
If you don't remember, then you can easily find. That's okay, but it will be little bit time consuming. That's the thing. So if you know the eigenstates of this Pauli matrix, then you can easily identify whether any options between these two will be correct or not. Okay. So okay, Amit. So you know that. So you got some hint, right? So just check for the other options. Okay.
Okay, sir.
Okay, and just let me know which is the correct one. And Pushkala, what about you? Are you there?
No, sir. Yes,
Okay.
sir.
So you forgot this thing, or I mean, what's the problem? Can you please tell me?
Sir, I have forgotten.
Okay, okay, okay. So so what I told already to Milan. So you know how to find the eigenstates, right? For a matrix.
Yes, sir.
No, no, Milan. I am talking to Pushkala now. Okay. Yeah, Pushkala. Pushkala, are you there? Yeah. So you know how to
Yes, sir.
find the eigenstate and eigenvalues for a matrix.
Yes, sir.
Yeah, I can't hear you.
Yes, sir. Yes, sir.
So can you please do that? What's the eigenvalues and eigenstate and how to do that? Can you please tell me at least? So Amit, I hope I will get the answer from you.
Sir, it is deep probably.
Not probably, you have to be sure. Already you got the 50-50 option. So
Yes.
we have to be sure.
We have to just multiply this
Aha.
matrix matrix with
You
the
have to
speed
take the
gradient.
inner product and then mod square.
Yes.
Yeah. Yeah. Okay. Let's not waste the time. Then I should go for the solution. Please look into it carefully, and if you have any confusion, please ask me. Okay. So, okay. So, given spin operator, that is Sx cap equals to h cut by 2 times this 2 cross 2 matrix, that is 0 1 1 0. So, this 0 1 0 1 0 is one of the Pauli matrix, that is sigma x. So, we can write it as h cut by 2 times sigma x, right? And so we have to find, we have to know the what are the eigenvalues and eigenvectors for this spin operated Sx cap matrix. Okay. So for that we have to, what we have to do, we have to take the determinant of this sigma x minus lambda times I2. So here lambda is the eigenvalues of this sigma matrix and I2 is the 2 cross 2 unit matrix, that is 1 0 0 1 matrix. Okay. So if we just do that, then what we will get, determinant of 0 1 1 0, that is the sigma x matrix, minus lambda times I2, that is 1 0 0 1. So if we take the determinant, then we will get from this matrix lambda square minus 1. So it is obvious that the eigenvalues for Pauli matrix will be plus minus 1. So the eigenvalues for Sx cap matrix will be just multiplied, you have to multiply h cut by 2 with this plus minus 1. Okay. So the eigenvalues for Sx cap will be, so will be plus minus h cut by 2. Okay. Is it clear to everyone?
Yes, sir.
Yes,
Okay,
sir.
fine. So the eigenvalues of spin operator Sx cap are plus h cut by 2 and minus h cut by 2, right? Now, so you have to find the eigenstates. So how will you do that? That you have to just consider a state, that is uv. So as this is a 2 cross 2 matrix, so the this state will be your column matrix with 2 elements, right? So I am considering it as uv. So according to a property of the eigenvalues and eigenvectors, so the operator multiplied with that eigenvector will be eigenvalue times the eigenvector, right? So you have the eigenvalues plus minus h cut by 2, and here you can write it Sx as h cut by 2 times sigma x. So h cut by 2 and h cut by 2 will be cancelled out from both sides. So you have 0 1 1 0 matrix times this column matrix uv, that is the eigenvector, plus minus this matrix uv. So essentially if you just multiply this two matrix, so you will get vu, this matrix, equals to plus minus uv. Okay. So is this clear, the concept of eigenstates?
Yes, sir.
Okay. Okay, fine. So you are getting the condition v equals to plus minus u. Okay. So for the eigenvalue plus h cut by 2, you have the plus sign obviously. So you will have v equals to u. And for the eigenvalue minus h cut by 2, you have v equals to minus u. Let us choose u equals to 1. So you will get v equals to 1 for plus h cut by 2, because v equals to u for plus h cut by 2 eigenvalue, and v equals to minus 1 for minus h cut by 2 eigenvalue. So your eigenvectors or eigenstates will be 1 1 for the eigenvalue plus h cut by 2 and 1 minus 1 for eigenvalue minus h cut by 2. So this is not normalized, just you have to do the normalization. So after normalization you will get 1 by root 2 1 1 state and 1 by root 2 1 minus 1. So for plus eigenvalue we consider it as upspin, and for minus eigenvalue we consider it as downspin. So the upspin state will be 1 by root 2 times this column matrix 1 1, and downspin state will be 1 by root 2 times this matrix 1 minus 1. So up to this, is it clear, right? Any confusion, guys?
No, sir.
Okay, so this thing you have to remember at least. So this is a very textbook thing. I have discussed this mathematics, but you should remember the eigenvalues. Obviously eigenvalues will be same for every problem matrix, but eigen vectors will be, so you have to remember that thing. So for sigma x, sigma y and sigma z, that three. Okay, now one more concept that will be required, that is, if any spin state phi is given upon the measurement of Sx cap, the probability for obtaining the upspin or downspin is given by this mod square of inner product between either upspin and that state or downspin or that state. So this is the way to find the probability of getting upspin or downspin upon the measurement of any kind of given state. So this you should remember. This will be required for checking the third and fourth option. Okay. So let us check all the options one by one. Okay. So the eigenstates of spin operator SS cap are upspin 1001. So this is not true. Obviously, we have found what are the actual eigenstates for the SS cap operator. So this is false. Okay. Now option B. So option B, it is given the eigenstates of spin operator SS cap are upspin is 1 by root 2 1 minus 1 and downspin it is given 1 by root 2 1 1. So this is given actually opposite. So this is not false because upspin is 1 1 and downspin is 1 minus 1. So this is also false. Okay. So now option C. In the spin state 1 by 2 times 1 root 3 matrix, upon the measurement of SS cap, the probability for obtaining upspin is 1/4. It is given in the option C. So let us check. So how to check that? I have already shared the concept how to find the probability. So it is given that given state is phi is this, and upspin state you already found the eigenstate of this SS cap upspin, that is 1 by root 2 1 1 matrix. Now just take the inner product and take the mod square of that. So upspin and this phi state. So that is given in the question, that is 1 by 2 times this matrix 1 root 3. So if you take the inner product, so what we will get? We will get this is for this upspin, the inner product between upspin and phi state, that is 1 by root 2 times this. Now it will be row matrix. Obviously, this is because of the bra of this upspin. So 1 1 times this phi state, that is 1 by 2 times column matrix 1 root 3, that is the given state. So you just do this calculation, just check the calculation here. So sorry, I think I have okay, yeah. So we are getting after calculation, that is 2 plus root 3 divided by 4, but in the option C it is given 1 by 4. So that is not true, right? So the actual answer is 2 plus root 3 by 4, and option D, it is given that probability is 2 plus root 3 by 4. So that option D is correct. Okay. So for this question, in the spin state 1 by 2 times 1 root 3 state, upon the measurement of SS cap, the probability for obtaining upspin is 2 plus root 3 by 4. Okay. So is this clear? Any confusion? Please ask me. Any
Yes,
doubt?
sir. Actually, why did I use the word probably? I want to clear because I
Ah,
didn't actually calculate also.
okay.
Um, when I operate this phi on Sx, then I'll be getting 1 root 3 term in the column matrix. So, and
Okay.
I know the basis states. So there is only 1 and minus 1 or
Huh, huh.
1 or 1. So there should be some root 3 term in the probability means cx square. So that's
Acha.
why 1 by 4 cannot be the
Oh,
option. So
okay.
I
Okay, got it, got it. But you have to do the properly, right? To make you sure
yes,
actually.
yes,
Yeah.
yes,
Okay. Fine. Pushkala, is did you understand the solution, the concepts?
Yes, yes,
Okay.
sir.
Okay. Milan, is it clear to you?
Yes, sir.
Okay.
Absolutely.
Anyone else joined? Okay. Shidita, you joined late, I think. So you understood that thing what I discussed now?
Yes, sir.
Okay. Fine. So okay. Okay. I hope my screen is visible.
yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
I am going ahead to the next question. Okay. So the next question is from GATE Physics paper 2020. This is a numerical answer type question having 2 marks, and this is from electromagnetic theory. And the question is, a sinusoidal voltage of the form V as a function of time equals to V naught cos omega t is applied across a parallel plate capacitor placed in vacuum. Ignoring the edge effects, the induced EMF within the region between the capacitor plates can be expressed as a power series in omega. The lowest non-vanishing exponent in omega is, so you have to find the lowest non-vanishing exponent in omega when you will expand the induced EMF in the power series. So is the question is clear? First read the question very carefully and let me know if the question is clear or not. Shidita, is this question is clear to you?
Yes, sir.
Okay, please try to solve this and let me know. I hope everyone has done the electromagnetism, read the electromagnetism chapters, the topic. Amit?
So I'm not sure how to approach this.
Okay,
Induced EMF I have minus d phi by dt,
absolutely.
um,
Hmm.
but phi is equals to b dot a.
For that, you
S-
have to find the B, right?
Yes, and
So,
here it is only given potential. Okay,
yes,
I can
you try.
um
So you have to go by step, okay. So you are given
yes,
something, you have to go one by one. So you have to so you are correct, you have to know the B to find the phi, and from the phi we
yes.
can find the induced EMF. That's correct. So
So
now think
from
how to find the
potential,
yeah.
so from potential, I can what I can think about is first finding the electric field
Yes,
from
yes.
E equals to negative grad of V, and then I can find the B, I think.
Yeah, electric field will be just your potential, given potential by divided by the capacitor distance, that is you can consider it
Yeah.
as D. You don't have
Yes.
to take the gradient also, because it's not like a special thing. In that case you
Okay.
can take the minus grad V, right?
Yes. Okay.
Yeah, so you know the electric field from here. So from that you just check how to find the magnetic field. Okay, then you find the flux, magnetic flux, and from that use the Lenz law, that is sorry, Faraday's law, to find the induced EMF. That's the steps.
Okay, sir.
And then what you will get, you just expand the whole thing. So what I have told now, is this clear? Is this understandable to Pushkala, Milan, and Shidita?
Yes, sir.
Okay. So okay, okay. So okay, let me talk to Shidita now. So what you have to do? Please, can you please tell me? Just tell me the steps. What I have told already.
First, we have to find electric field by
So what will
divide
be
by
the electric
current.
field here if the capacitor plate distance is d? Let us test small
Uh,
d.
Voltage by distance between two plates.
So that will be V naught cos omega t by the distance d, right?
Yes, sir.
Okay. So if you know the electric field, now how will you find the magnetic field? What equation you will use to find the magnetic field for the corresponding time varying electric field?
Maxwell's
Yeah, that's the correct. Which equation? That I am asking. That you have to know. Otherwise, how will you find the magnetic field? So, what is the equation that relates the B and that electric field?
Curl of E equals to negative del B del T.
That is also correct. But here you can see one thing. Here it is not the spatial thing, right?
Oh yes.
Right. So
Yes.
we are already given the time dependence of electric field, right? So that
Yes.
equation you can't use. I don't think so. You can use there. So
Okay.
what is the other equation? What is the other equation? One more equation is there to that will connect the magnetic field and electric field. So for the capacitor plate, you
Uh,
you
curl
know, yeah.
del by del T.
Yes. So what's the equation? So that is curl of B equals to something. What is that? Amit, are you there?
Yes, sir, but can't remember. Sorry.
That is the fourth equation. That is called modified
Um,
Ampere's law, I think. Yeah.
okay, mu naught J plus mu naught epsilon naught del E del T.
Yes. So in this case, for capacitor, you will have only displacement current, right, between the plate. You will not have any conduction current, right?
Yes.
So that JD, so curl of B will be your mu naught times JD. So that is the displacement current density, and displacement current density is your epsilon naught times daily del T, right? So the
Yes.
equation here will be curl of B equals to mu naught epsilon naught times daily del T. So here you are getting the temporal part or time dependent part of the electric field. So you can use this equation here to find the magnetic field between the capacitor EG, right? So please let me know what are you getting the magnetic field expression. Just consider the capacitor plate distance is small d. Did you guys get my point? What I
Yes,
told?
sir, yes, sir.
Okay.
Means if I differentiate it with time, means only the cost part I'm concerned about, then I'll get sine, and then we have to expand it. So the lowest non-vanishing term will be 1.
This is for magnetic field,
Uh,
but you have to find the actually induced EMF.
okay. Yes, yes.
Just check it.
So it will be again differentiated. So again it will be cost. So 2 is the answer.
Okay. Anyone else?
No, sir, cos will be there. So 2, right?
No. For cos, why it will be 2?
We expand sir cos series.
So what is the expansion of cosine of omega t?
1 minus omega square t square by 2
So
plus
lowest non-vanishing exponent in omega in that?
1.
No, according to you, it should be then 0, right?
Uh,
Omega to the power 0. That is 1, right?
hmm.
So your answer is
Oh,
0.
okay.
So you have to check whether any other omega term is coming in the expression or not, because don't just go with the term cos omega t. There should be another omega term, maybe omega square outside the cosine. So you have to check that, right?
Yes, yes.
Yeah. Okay. Pushkala and Siddhartha, what about you? Did you try it or
Sir, I have tried it. I think in the series it will be the second term, which is non-vanishing exponent.
okay?
So
Huh?
there is a omega square term outside. So 2 will be the answer.
Who is this?
So Amit.
Okay, Amit is saying two, and anyone Pushkala, what are you saying? Can you please repeat?
I'm saying that in power series it will be the second term, which is lowest non-vanishing exponent.
Okay, second term you are saying. Okay,
Yes, sir.
so second term in the power series you are getting what?
No, I didn't did that. I'm just
Okay,
going with the theory.
sorry.
I didn't did that, sir. I just guessed with the theory that I studied before.
Okay, okay, okay. Okay, fine. So let me discuss the solution and let me check whether the Amit is getting the correct answer or not. Okay. Also, the please understand the solution, the step by step. It may be helpful in other questions also, because not only to get the correct answer, you should be clear about the concepts also in this case. Okay. So how to find the magnetic field and everything. Okay. So it is given that a sinusoidal voltage of the form the potential V as a function of t equals to V naught cos omega t. So that is applied across the capacitor plate. Let the separation between capacitor plates be small d. So the electric field between the plates is E equals to the given potential or voltage divided by d. So it will be V naught by d times cos omega t. Now, what we have considered here in the schematic, we have considered a circular loop having radius smaller at the center of the capacitor plate. So, in the region. So, what will calculate the magnetic field or anything induced EMF along this circular loop. Okay, and the shaded region will be the area of the circular loop. Okay. So, we have to, as I have already discussed, the Maxwell's equation will be used here, that is curl of B equals to mu naught epsilon naught times daily del T. So, here we have to take the surface integral both side. So, that will give the surface integral of curl of B equals to mu naught epsilon naught times the surface integral of daily del T. So, we can just convert this surface integral into closed path integral. So, that will be closed path integral of B of dl equals to mu naught epsilon naught times the surface integral daily del T times ds. Okay. So, along this loop you can find the closed path integral of B, that will be B times 2 pi r, right, and here you will get daily del T will be your minus V naught omega sin omega t divided by d, because E is your V naught by d times cos omega t, and derivative of cos omega t you will give you minus omega times sin omega t. Okay, and for ds surface integral you will get the surface area of this loop, that will be pi r square. So eventually you are getting a magnetic field which is minus r times mu naught epsilon naught V naught divided by 2d times omega sin omega t. So is this clear to everyone?
Yes, sir.
Okay, fine. So now
Yes, sir.
induced EMF is given by the Faraday's law, that is E equals to minus d phi dt. So if you have time varying flux, magnetic flux, then that will induce a EMF along the loop. So here phi is your magnetic flux, that is magnetic field times the area of the loop or area of the region what you are considering here. So as the magnetic field is time varying, so your flux will be time varying, and hence you will get a induced EMF. So here you can write it induced EMF as minus A times dB dt. So B you know already from the earlier slide. So here only concerned term is time dependent omega sin omega t. So you will get the special part also another constants times omega square cos omega t. Why? Because sin omega t time derivative will give it omega cos omega t, and another omega is there, so it will give omega square cos omega t. So you just expand the cos omega t, that will give, I mean, you know, cos theta equals to 1 minus theta square by 2 factorial plus theta over 4 factorial plus so on. So you just expand it like that, and here one extra omega square is coming out of the parenthesis, so you just multiply that. So the non-vanishing exponent in omega is here 2, right? So Amit was correct. So the answer is 2 for this question. So is the solution is okay with everyone?
Yes, sir. It is clear, but I have
Yes,
one more
sir.
question.
Huh, sorry.
I have one more question
Yeah, yeah, yeah.
similar to this type. So I'm asking this. So, can you go back a slide?
This slide or this
Yes.
slide?
Yes. No, no. After that, yes. So from this Maxwell equation,
Mm-hmm.
if I'm given
Mm-hmm.
del b del y is equal to del e del t, then can I know in which direction is b,
Sorry.
means the direction of b, can I know from that?
So direction of B, you know, right? What direction of B is? That will be radially outwards, right?
No, means not in this case. Means I'm remembering a
Haha.
question from TIFR,
Okay, okay.
which was given. I can't remember it exactly, but there only two equations were given, like del E del x equals to
Mm-hmm.
del b del t, and del b del y equals to del E del T, something like that.
Okay,
So, and then they were asking what are the directions of E and B.
okay,
So, how can I know that from this equation?
okay. Okay, just give me 1 minute. Let me think. I mean, I have to understand
Okay.
your question actually. So you are
Okay.
given del E del X. Okay.
By the time I'll try to search the question also.
Okay, you can, one thing you can do that will be better. You can send me the question so that I can discuss in the next class. So that will be better for me to
Okay. Okay.
understand the question and I can give a idea how to understand that thing. There
Okay.
obviously there
Okay.
is some proper way to understand the direction, but that depends on the question how to deal with this. Okay,
Yes.
so
Yes. Yes.
I mean that basic thing you know already, that E and B will be for T of E and B will be perpendicular and your propagation vector will be perpendicular to both of these, right? But that depends on
Yes.
the question, the how it is given in the question actually. Yeah. So please send me the question. I can tell you how to understand from the Maxwell's equation actually.
Okay. So I remember another question which came yesterday in TIFR exam.
Oh, you had the TIFED
If
exam
you,
yesterday?
yes. Yes. Yes.
Oh, okay, okay, okay.
If you allow me, then I can share the question.
Hmm, hmm, hmm.
Um, Yes, so there was a question regarding EMT. They asked that in a T means if a electromagnetic wave is traveling in the
Hmm, hmm.
what we call that waveguide.
Okay.
Yes, so the electric and magnetic field will be perpendicular in which case? So there were options like every time, and then only in TE mode, only in TM mode, or never. So
Electric field and magnetic field is perpendicular to. I didn't get your question. Can you repeat the question first?
the electric and magnetic fields
Ha ha ha.
will be perpendicular to each other.
Acha,
In which case?
that is TEM mode. Okay. Ha. Just tell me.
Uh, in which case? So the options were given in all cases in TE mode only,
Hmm.
in TM mode only,
Hmm.
and never.
TEM mode cannot. What I
No,
remembered. I have to just
there
check.
was
Cannot
not.
exist in waveguide, right?
Yes, yes,
Because I have to check. I mean, what I remember, because there's some calculation involved in this. Because I think TM mode or TE mode can travel through the waveguide, because of the constriction of the
yes, yes,
waveguide.
yes.
Team
But the
T
question was,
ha
sir,
ha.
question was the electric field and magnetic field directions will be perpendicular in which case? So I think
Perpendicular to mutually perpendicular,
yes,
right? You are saying.
yes, mutually perpendicular. It should be every time. I think.
Uh, See, TM, okay. So why you think that should be every time? TEM mode is the only thing that is the uh, your propagation. Okay, you are saying that. Okay.
I mean, in the waveguide,
Mhm.
there is. there are conditions like TE, TEM, and TEM. So I think from what I understood that in different cases, one is transverse, other is not.
Right, exactly.
So, but these two E and B are always mutually perpendicular because otherwise, how can we apply the Maxwell's equations?
uh, okay, no, so how?
Electromagnetic field should be always means electric and magnetic fields should be always mutually perpendicular in EM waves,
No,
right?
that is true only for TEM mode. TEM mode. That's why it's called transverse electromagnetic mode. So that's not always true that your electric field magnetic field should be mutually perpendicular every time.
Okay.
There should be component along the B magnetic field. That's why there is TE and TM mode. I may be wrong, but I think the answer is will be none of this. But I will check. Please send me the question. You can write the question and please send me. I will check clearly.
Um, I exactly don't remember the whole
Okay, okay,
question,
okay.
and the question paper is not out yet.
Oh, okay, okay. So I will just revise that thing because I also forgot this waveguide part a little bit. So I'll just check and I can clarify in the next session. I'll remember this question. I can clarify the concepts. I mean, what you are saying, I will remember, and
Yes, yes, yes.
what I'll just check. Okay.
Actually, I need the concept only
Okay, okay. I
because
I I, I remembered the question. I got your point. So I'll just check the part waveguide. So I didn't study it for a long time these things. So I have to
yes,
just
yes,
check.
yes.
Okay. Right.
Okay, sir. Okay.
Okay. Okay. Fine. So we'll discuss the last question very quickly. So this question is from Gateway's 2020. This is a numerical answer type question having 2 marks from quantum statistics. So the question is, consider a gas of hydrogen atoms in the atmosphere of the sun where the temperature is 5800 Kelvin. If a sample from this atmosphere contains 6.023 times 10 to the power 23, that is Avogadro number of hydrogen atoms in the ground state, the number of hydrogen atoms in the first excited state is approximately given 8 into 10 to the power n. Here n is the integer. So you have to find the value of n here. And also given the Boltzmann constant is 8.617 times 10 to the power minus 5 with the unit electron volt per Kelvin. So first read the question and let me know if there is any confusion with the question first. So this is so I want to know what will be your approach to solve this problem first. I don't need the answer exactly. First, let me know the approach.
So do we have to find the energy difference between ground and excited state?
Yes, you have to know that for that because here it is already shown a ground state and it's a first X-ray state. So you have to know the hydrogen atoms energy levels, ground state and first X-ray state. Yeah, that's true. So then what will you apply? That will give you the energy difference, but you have to use the energy difference in some way to find the number of atoms. Find the number of atoms. So for that, what will you use?
For that, we know from Maxwell's statistic, n naught equals to n naught e to the power minus
Right.
beta e.
Right, right, exactly. By E by K minus E by KBT. Right. So
Yes.
yes. So can you just tell me why will you use that Maxwell statistics here? Although hydrogen is a quantum particle, quantum atom, atom is a quantum particle.
But the distribution of
Hmm.
the gas particles will be means it will follow the what that distribution. I forgot the name of the distribution. Maxwell distribution, I think.
That's not the exact reason. So it depends on the temperature scale. Okay, so here just check the temperature
Okay.
is too high. So at that high
Yes, two.
temperature, your gas will be classical. If you have, so you have read about cold atoms, right? That acts as a quantum particle. Not you cannot use the Maxwell-Boltzmann distribution there. You have to use proper the Fermi-Dirac or Bose-Einstein distribution. But in this case, the
Okay.
temperature is very high. That's why you have to use the Maxwell-Boltzmann. So usually at room temperature and above, we use the Maxwell distribution to find the number of particles, right? So you are right that Maxwell-Boltzmann you have to use here. So just use that and let me know what should be the answer. Okay, Amit?
Yes, sir.
Okay. So the idea is you have to find the energy difference between the first the ground state and the first excited state of the hydrogen atom that you know already. That is, I'll tell you, that is will be minus 13.6 by n square electron volt, where n is the principal number for the hydrogen atom problem. So for ground state it will be n equals to 1, and for first excited state n will be 2. So you know the energy values, just take the difference so that you know the del E. Now you have to use the Maxwell-Boltzmann distribution that will be applicable for the ground state also and first excited state also. Take the ratio. One thing you know, the ground state given number is this, and first excited state is given in this form. Just take that ratio and use that energy difference value and find the this integer n value from that equation. So I told everything, just let me know the n value here. Okay. Okay, so Amit, you were asking about the the TETM mode, right?
Yes,
So
yes.
I was just checking. I mean, I forgot almost of everything, but I was checking, and what I remembered also. So your electric field is transverse to the direction of propagation. That will be correct. But your magnetic field is not only transverse. Okay, so there will be component of longitudinal component also. Okay,
Okay.
so they will not be mutually perpendicular every time. So that's the thing I remembered also, and you also tell me. So I think the answer will be none of this from your
Okay.
options. Hmm.
Okay. Okay.
Okay, just check the theory part. I think you will understand from the theory part.
Yes. Okay. Thank you, sir.
Yeah. Are you guys trying this question?
Yes, sir.
Okay. And other guys, Shidita, Milan.
Yes, sir. Yes, sir. Trying.
Okay.
Yes, sir.
Okay. Any answer, guys?
Sir, it is 8.22 into 10 raised to 14.
Sorry, 8 into
Uh, So, yeah.
Yeah.
N1 is equal
Huh.
N1 is equal to 8.22 into 10 raised to the power 14.
So the n value will be here 14.
14, yes, sir.
Okay. Okay. Anyone else? Amit, Shitita, Pushkala, anyone?
So
Yes, yes.
I'm only with my calculator of laptop, and I'm
Oh,
not.
okay, okay. So what calculation you need? You can tell me. I can tell you from here. I mean,
So
yeah. So you are
so
stuck. You are
actually,
stuck at the e to the power
yes,
daily by
yes,
kbt, right?
yes, yes.
So
I know the Delhi will be minus 13.6 plus 3.4. That is minus 10.2.
plus
And
10.2
then
will be e2 minus e1 will take, right? Into sorry, n1 by n2 if you take, then it will be plus, or yeah, okay, minus yeah, just tell me e to the power minus 10.2, yeah.
and then the beta value means 1 over 5,800 times
Ah,
kb. Kb is given here. Okay.
kb is
In
given and t is 5800, yeah, this thing.
yes,
So but okay, yeah. Hmm.
and then so
Hmm.
we multiply this with 6.023 into 10 to the power 23.
So you can keep it in electron volt also. I mean, because everything your energy difference is in electron volt and kb is given also in electron volt, right? So
Yes.
okay, fine. So that exponential part, I can tell you the that part value will be your e to the power 10.2 divided by kbt. That value will be 7.16 times 10 to the power 8. What you will get? You got
So
my
it's
point? Once
7.16.
7.16 times 10 to the power 8.
Okay.
That exponential part will give you the value. So I am considering the plus e to the power plus daily by kbt. Okay. Now
Okay.
you just check it. You can take the reciprocal if you need e to the power minus.
Okay, sir.
Okay. Just check the order of magnitude. That will give you the answer. You don't have to really have to find the exact value also here, because you need the 10 to the power n, that n value. Okay, so Siddhita, did you try or are you stuck anywhere? Because it has been almost 10 minutes. Also, didn't guys ask any question?
Yes, it's coming 14.
Okay. Okay. Okay, let me discuss the solution then. Okay, Amit, I think you will get the answer if you have the calculator. Okay.
Yes, sir.
Okay. So already I discussed the solution. So just let me go through it formally. So it is given a gas of hydrogen atoms in the atmosphere of the sun, where the temperature is T equals to 5800 Kelvin, right? Now we know the energy levels of hydrogen atom, that is given by En equals to minus 13.6 by n square electron volt. N is the principal number that takes the values, the integer values 1, 2 and so on. So for first excited state, it will be n equals to 2. So for that, the energy value will be minus 3.4 electron volt. And for the ground state, n equals to 1. So the energy value will be minus 13.6 electron volt, right? Now, according to Maxwell-Boltzmann distribution, the number of classical particles in an energy level E at temperature T is proportional to e to the power minus E by kBt, where E is the energy at that state. Okay.
Sir,
Yeah.
sir, sorry to interrupt. I'm getting 8.41 into 10 to the power 14.
So your n value should be 14, right?
Yes.
And what's the 8 into 10 power 14? Okay, yeah. So 14 is the correct answer, right? So if you get the
Okay.
answer 14 or 15 also, so there is a range 14 to 15, that is also correct. So they, because they need the order of magnitude, someone can calculate only the order of magnitude only, not the exact number. Okay, so that's the that will be okay, 14 or 15. Okay, so let in1 and in2 be the number of hydrogen atoms in the ground state and first excited state. Then what we can write from the Maxwell-Boltzmann distribution, in1 by in2 equals to e to the power minus e1 by kbt divided by e to the power minus e2 by kbt. Now if you take this ratio, then it will give e to the power e2 minus e1 divided by kbt. Now in1 is given the number of hydrogen atoms in the ground state, that is Avogadro number 6.023 times 10 to the power 23, and in2 is given in the form 8 into 10 to the power n. T is given 5800 Kelvin, and we have already E2 equals to minus 3.4 electron volt, E1 equals to minus 13.6 electron volt. So E2 minus E1 will be 10.2 electron volt. Okay, and we have to find the KBT. Okay, so here I have done little, I have not actually considered that value. You can directly find the KBT value in electron volt by multiplying the temperature 5800 with the KV value. So here I have used the actual value, but it doesn't matter. You will get the KBT value for T equals to 5800 Kelvin, that will be 0.50025 electron volt. Okay, so your in1 by in2 will be e to the power e2 minus e1, that will be 10.2, and kbt is 0.50025. So, and this part will be 6.023 times 10 to the power 23 divided by 8 into 10 to the power n. So, this will give you e to the power exponential of 20.3898, that you have to use your calculator for this. Now that exponential value actually is 7.16 times 10 to the power 8. So you can just take the 10 to the power in part on the left side and remaining part in the right hand side. So if you just calculate that, you will get approximately 10 to the power 40. So your in value will be 40. If you get also 15 also, that is also correct, because in the answer I checked, it was given in the range 14 to 50. Okay, so according to my solution, the answer is 40. Okay, fine.
Okay, sir.
Okay, thank you, guys. Just if you have not subscribed my YouTube channel, please subscribe, and just hold on, let me take a screenshot for this record of this class, and I have already shared in the chat box. If you are not subscribed yet, please subscribe. I will update the solution part on my channel. Okay, and also please inform your friends also, so that we can grow our channel. Okay.
Yes, sir.
Okay.
Definitely. And thank you, sir. I'll send the
You can
question
send me the
later.
question. I'll check. I'll reply within 1 or 2 days, because I am attending a conference, so I'll be busy from
No
tomorrow.
problem, sir. No
Yeah,
problem.
so it's a fine. Okay, thank you guys.
Thank you, sir.
Thank
Thank you.
Thank you, sir.
Bye.
Thank you.
Bye bye.